Given the gradient function or derivative function dy dx equals 15x squared, we're required to find y in terms of x. Now, with differentiation, we're given a function, a curve, and we differentiate that function. We find the derivative function or gradient function. So we differentiate. What we're doing now is we are given the differential, we're given the derivative function, the gradient function, and we are performing reverse differentiation, in other words, integration. So we'll be integrating these expressions. So the integral dy dx will give us the function y. The integral of 15x squared, 15 is a constant, so we can pull it out of the integration. And since we are performing the reverse of differentiation, we can add 1 to the exponent, so we'll have x to the 3, and we divide by this exponent. So we add 1 to the exponent and divide by the new exponent. But with integration, we also have a constant of integration, and I'll explain that to you now. So y equals 5x cubed plus c. The reason we have a constant of integration is when we differentiate this function now, when we find dy dx, 5 times 3 is 15, and then we'll have x squared. When we differentiate a constant, we always get 0. The derivative of a constant is always 0. That's why when we integrate an expression, we always have to add a constant of integration, because when we find the derivative of that expression, the derivative of a constant is 0. Given dy dx equals 14x to the 6, to find y in terms of x, we integrate these expressions. So y equals, and we just have a dx over here, which just means we're integrating with respect to x. 14 is a constant term, so that doesn't take any part in integration. We then take the expression we're integrating x to the 6, and we're integrating with respect to x. Anything that is not an x, so-called x term, is not part of the integration. So we add 1 to the exponent, 6 plus 1 equals 7, and we divide by 7, and we add the constant of integration as well. So y equals 14 divided by 7 is 2, 2x to the 7 plus c. This is y in terms of x. Now, we'll check this integration by finding the derivative of this expression. So dy dx equals 7 times 2, 14, x to the 7 minus 1, x to the 6, and the derivative of a constant is 0. Given dy dx equals 12x cubed, integrating both sides gives us y equals 12 times x to the 3 plus 1, x to the 4, divided by 4, plus the constant of integration. So y equals 12 divided by 4 is 3, 3x to the 4 plus c. This is y in terms of x. If we differentiate this function, we will have 4 times 3 is 12, x to the 4 minus 1, 12x to the 3, and the derivative of a constant is 0. dy dx equals 3 over x squared. Now, before we integrate, this is not in a form that we can integrate, that we can use. Much like with differentiation, we needed to get the function in differentiable ready form. We've got to do the same thing when we integrate. So the first thing we do is just get this into a form that we can integrate. So that equals 3x to the minus 2, and now we are ready to integrate. Now that we have this expression in a form we can integrate, we'll integrate the expression. So y equals 3 times x to the minus 2 plus 1, x to the minus 1, then we divide by minus 1, and we add a constant of integration. So y equals minus 3x to the minus 1 plus c. Written in a better form is y equals minus 3 over x plus c. We're going to check the integration by differentiating this expression. Y equals minus 3x to the minus 1 plus c. dy dx equals minus 1 times minus 3 is 3, x to the minus 1 minus 1, x to the minus 2, the derivative of constant is 0. So dy dx equals 3 over x squared. Dy dx equals 1 over 2x to the 3 again. This is not in a form that we can integrate. So we will first put it into a form that we can integrate. So it's x to the minus 3 over 2 dy dx equals x to the minus 3 over 2. We can now integrate y equals, a half is a constant, so we'll take that out. X to the minus 3 plus 1, x to the minus 2, divide by minus 2, and add the constant of integration. So y equals minus a quarter, x to the minus 2 plus c. When written in a better form, that's minus 1 over 4x squared plus c. Again, we're going to check the integration. By differentiating this expression, dy dx equals minus 2 times minus a quarter is a half, x to the minus 2 minus 1, x to the minus 3, the derivative of constant is 0. So written in a better form, dy dx equals 1 over 2x cubed. Dy dx equals 4 over root x. Again, this is not in a form that we can work with, so we write it as 4 over, we write root x as a power, which is root x is x to the half, and dy dx therefore equals 4x to the minus a half. This is in a form that we can integrate now. So the integral of dy dx equals the integral 4x to the minus a half dx. Y equals 4 times x to the minus a half plus 1 is x to the half, and we divide by a half and add the constant of integration. Y equals 4 divided by a half is the same as 4 times 2, which is 8 x to the half plus c. Now I'm going to check the integration by differentiating. So dy dx equals 8 times a half is 4, x to the half minus 1, x to the minus a half, and the derivative of constant is 0. Dy dx equals 4 over x to a half. In a better form, that's 4 over root x. This is a very similar exercise, just using a different notation. So instead of using the notation y equals something, an expression in terms of x, we're now using the notation f of x equals, and we know from functions that y equals f of x. They're just the same thing, expressed differently. So we're required to find f of x given f prime x in each case. Now f prime x is the same as dy dx. We are given the derivative function or the gradient function, and we're required to find the expression from which we found that derivative. So f prime x equals 5x to the 4 minus 2x cubed plus 2. To find f of x, we integrate this with respect to x. So f of x equals 5 as a constant, doesn't take part in integration, times x to the 4 plus 1, so x to the 5 divided by 5. We can add the constant of integration right at the end. We can integrate essentially every single term. You can express this as 3 separate integrals, but it's not necessary. We just can integrate each of these terms on its own merits. Then we take minus 2 as a constant. It takes no part in integration. X to the 3 plus 1, so x to the 4 divided by 4. And then plus 2 times. Now 2 is 2 times 1, which is, in terms of x, 2x to the 0. So we have x to the 0 plus 1, x to the 1, and then divide by 1. And now finally we add the constant of integration. So f of x equals 5 divided by 5 times x to the 5. We have x to the 5 minus 2 divided by 4, so it's minus a half. X to the 4 plus 2x plus c. Now we're going to check this by differentiating f of x. So f prime x equals 5x to the 4 minus 4 times a half is 2, that's 2x cubed plus 2, and the derivative of a constant is 0. And this is the expression that we have. B is done in a very similar manner as A, so we're just going to go straight to C because we have denominators here. Well, then D will be very similar to C, so we're just going to do C now. F prime x equals 2 over x cubed plus 8 over x squared plus 6x. Before we can integrate this expression, we need to put it into a form that we can integrate. So f prime x equals 2x to the minus 3 plus 8x to the minus 2 plus 6x. We're now ready to integrate this. So f of x equals 2 is a constant, doesn't take part in integration. X to the minus 3, we integrate minus 3, we add 1 to the exponent, x to the minus 3 plus 1, x to the minus 2, divide by minus 2, plus 8 times x to the minus 2 plus 1, so x to the minus 1, divided by minus 1, plus 6 times, this is x to the 1, so it's x to the 1 plus 1 is x to the 2 divided by 2, and finally we add the constant of integration. So f of x equals 2 divided by minus 2 is minus 1, so minus x to the minus 2, 8 divided by minus 1, minus 8x to the minus 1, 6 divided by 2 is 3, so 3x squared plus c. Now we're going to check our integration by differentiating. So f prime x equals minus 2 times minus 1 is 2, x to the minus 2 minus 1, x to the minus 3, minus 1 times minus 8, plus 8, x to the minus 1 minus 1, x to the minus 2, plus 3 times 2 is 6, x to the 2 minus 1 is x, and the derivative of constant is 0. So putting this into a neater form, we have 2 over, f prime x is 2 over x cubed, plus 8 over x squared, plus 6x, which is the expression we had for f prime x. Now f of x is written in a better form as minus 1 over x squared minus 8 over x plus 3x squared plus c. In this exercise, for each of the questions, we need to get the expression into a form that we can integrate. So starting with a, dy dx equals x times x plus 12. Now, we don't have to multiply out. There is what is known as the product rule of differentiation, but the product rule of differentiation is only for paper 2 and paper 3, and we're only concerned with paper 1. So we have to multiply out. So we'll have dy dx equals x squared plus 5x, and now we integrate the expression, so we'll have y equals x to the 2 plus 1, x to the 3 divided by 3, plus 5x to the 1 plus 1, 5x to the 2 divided by 2, and we add the constant of integration. This is maybe written in a nicer form as a third x cubed plus 5 over 2x squared plus c, and again we are going to check our integration by differentiating this expression. So dy dx equals 3 times a third is 1, x to the 3 minus 1, x squared, 5 over 2 times 2 is 5. X to the 2 minus 1 is just x to the 1. And the derivative of a constant is 0. So dy dx equals x squared plus 5x, which is x times x plus 5. We proceed in a very similar manner. We're just going to multiply the term outside the brackets into the brackets. We're first going to multiply out and simplify the product of these binomials, and then x times whatever that result is. So we're just going to move straight to d. dy dx equals x to the 4 minus 2x plus 5 over 2x cubed. Now, because we have, again, there is a quotient rule for differentiation and for integration, but that is only part of paper 2 and paper 3. So we are going to have to divide each of these terms in the numerator by the denominator. The denominator is a single monomial. It is a monomial. It's a single term. So we will have x to the 4 over 2x to the 3 minus 2x over 2x to the 3 plus 5 over 2x to the 3. So dy dx equals, we're going to write this in a form that we can integrate. So we're going to take the powers of the bottom to the top. So the x to the 4 minus 3, x to the 1, and that is times a half, minus 2 divided by 2, and then x to the 1 minus 3, it's x to the minus 2, plus 5 over 2, x to the minus 3. And we can now integrate this expression. So y equals a half times x to the 1 plus 1, so x to the 2 divided by 2, minus x to the minus 2 plus 1, x to the minus 1 divided by minus 1, plus 5 over 2, x to the minus 3 plus 1, x to the minus 2 times, if you like, times 1 over minus 2, plus c. So y equals a quarter x squared plus x to the minus 1 minus 5 over 4 x to the minus 2 plus c. And if we differentiate this, we get a half x minus x to the minus 2 plus 5 over 2x to the minus 3. Dy dx equals the square root of x times x minus 3 all squared. Again, we are going to have to multiply out these brackets first. So we'll have x squared, root x times x squared minus 6x plus 9. Root x we write as x to the half. So dy dx equals, and now we bring x to the half into brackets. So x to the 2 plus a half, 2 and a half is 5 over 2, minus 6x to the 1 plus a half, 1 and a half, which is 3 over 2, plus 9x to the half. And we can now integrate. So y equals x to the 5 over 2 plus 1. It's going to be 7 over 2, and we divide by 7 over 2, minus 6 times x to the 3 over 2 plus 1 is 5 over 2. We divide by 5 over 2 plus 9x to the half plus 1 is 3 over 2. We divide by 3 over 2 and then add the constant of integration. So y equals 2 over 7 x to the 7 over 2 minus 12 over 5 x to the 5 over 2 plus 6x to the 3 over 2 plus c. And if we differentiate this function, we get 7 over 2 times 2 over 7 is 1. X to the 7 over 2 minus 1 is x to the 5 over 2. Minus 12 over 5 times 5 over 2 is minus 6. x to the 5 over 2 minus 1 is x to the 3 over 2 plus 6 times 3 over 2 is 9. X to the 3 over 2 minus 1 is going to be x to the half, and the derivative of constant is 0. Again, and we get the expression for dy dx. F dy dx equals 5x squared plus 3x plus 1 over root x. Again, we've got to get this into a form that we can integrate. So first we're going to write the root x as a power. So we have 5x squared plus 3x plus 1 over x to the half. Then we divide each of the terms in the numerator by the denominator. So 5x squared over x to the half plus 3x over x to the half plus 1 over x to the half. And we need to put this into a form we can integrate. So we'll have 5x to the 2 minus a half. So it's 5x to the 3 over 2 plus 3x to the 1 minus a half, x to the half, plus x to the minus a half. And we can now integrate this expression. So y equals 5 times x to the 3 over 2 plus 1 is x to the 5 over 2, and we divide by 5 over 2 plus 3 times x to the half plus 1, x to the 3 over 2, we divide by 3 over 2, plus x to the minus half plus 1 is x to the half, we divide by a half and add the constant of integration. So y equals 5 divided by 5 over 2, that's going to be 2x to the 5 over 2 plus 2x to the 3 over 2 plus 2x to the half and we can check this by differentiating. So dy dx equals 2 times 5 over 2, that's going to be 5x to the 5 over 2 minus 1, x to the 3 over 2, plus 2 times 3 over 2 will be 3, x to the 3 over 2 minus 1, x to the half, plus 2 times the half is 1, and that's x to the half minus 1, x to the minus a half, and the derivative constant is 0. And this is the expression that we had for dy dx.